so far.
I think this is an awesome topic of discussion. But
let's do the segue. What started his career? Let's jump on the segue.
Exactly.
And then start now. What career?
What career?
What career?
Yeah. Who is Lars Albertsson?
Who is Lars Albertsson?
Yes. So my first career steps was during university. I worked a bit at IBM with OS2 systems. Not a lot of people have worked with those.
I did, actually.
At the time, I thought that IBM had this cool level of automation, but I have afterwards realized that's where I first encountered the going from craft to factory. Because back then I had a Windows 3.11 machine at home, like a Pentium 120, and it was really a pet, right? You massaged it, and if it had a virus, that would be terrible, and you had to work so much just to keep it alive, right? And you could see that out in the professional world. You had to spend lots of time just keeping the Windows machines alive.
That was your pet by then. I like that comparison.
And when we
Tamagotchi.
When I worked at IBM, we didn't treat these OS2 machines as pets, because whenever something was wrong with them, we just went with floppy, we booted them, and they would contact this installation server, and they would be rebuilt from scratch. From the definitions in the floppy, and they would probe the hardware and install the right drivers and reboot 11 times and so forth. Some people got confused and said, "Who deleted my local files that I put on this machine?" Because that's what we're used to. But essentially, with that OS2 installation, you had gone from a craftsman working with craftsman's tools and shaping your car in your garage to a factory where you build things from scratch. Now, this is the same way that we build containers today. And this is the same way that we build data sets in a modern data environment.
So this was your first encounter with factory thinking?
Exactly, with factory thinking. It was, we could administrate like many dozens of those machines with very, very little effort. So from there, at the end of my studies, I did my master's thesis in the Center for Parallel Computing in Stockholm. So it was a traditional sort of high-performance computing environment, working with data visualization and parallel computation. I moved on to SIX, Swedish Institute of Computer Science, stayed there for like 10 years, doing research in mostly in distributed systems and to some degree in networking. I ran one of the first IP version 6 nodes in Sweden, or the first IP version 6 node in Sweden back then.
Cool.
And that...
when is this?
I started there 97. I shut down the node in 2006. This was the 6-bone, the experimental network, and it was killed on June 6th, 2006.
To remember it.
Exactly. And then I felt that
the 6th of the 6th, yeah.
Maybe I was done with academia. I got to the stage of almost having a dissertation, but I realized, in a sense, what I had done could not be used because it was tied to proprietary hardware or proprietary software, and it wasn't as valuable as I thought. So I ran out of steam before I did my PhD. And when I thought it was time to change tracks, a Google recruiter called.
So before that, but you started some PhD work, right?
Yes.
And what was the topic of that?
So the topic was to use virtualization, this was before like VMware and so forth. But you use that type of instruction level virtualization for the purpose of debugging and testing and analyzing distributed and multi-threaded systems. So I built on top of a simulator, which was the name for the virtualization at the time. I built like debuggers so you could go probe into the virtual machines and look at their state in the same way as you would debug normal programs.
So you can say you started working with a precursor to Dockers before, and you started to work with a precursor to the virtual machines we all use today in cloud computing?
In a sense, the purpose of these machines were not to run things in production, but to study They were at first used for evaluating hardware, like simulating cache hierarchies and so forth. I did a sabbatical at Sun Microsystems building hardware, and we used these simulators to validate that the systems worked as expected. And sort of to run
like a simulation environment in some way.
Yeah, exactly. And there were a couple of these. Nowadays, the only popular open source one is called QEMU, but that wasn't really around at the time. This was a Swedish thing called Semix. They eventually got bought by Intel. There was a competing one from Stanford called SimOS, and that one never got commercialized, I think, but the research group that did that eventually moved on to do research called Disco, and that became VMware.
Oh, right.
And at the time, we were also collaborating with a group in Cambridge around, and they moved on to do Zen, which is one of the popular virtualizations today. I think it drives AWS, if I'm not correct.
Oh, really?
Mistaken. Yeah.
But Google Recruiter, that sounds interesting. So what happened then?
Yes, and this was 2007. It's now a long time ago, and that was at sort of the height of the Google hype. So that was interesting, and they were looking for SREs at the time, and that was
SREs.
Yeah, software reliability engineers. The SRE concept is you could call it Google's implementation of the DevOps philosophy, but both DevOps and SREs were completely unknown concepts at the time. And you have to have a certain, in order to work as an SRE, you have to tick off many boxes in your resume, like coding and testing and operating systems and networking and yada yada. And I happened to tick all of them, so I showed up in their recruitment scans.
So then when they did the sort or the search, you had one of the resumes that fitted that.
Exactly, they fitted all of the check boxes, right? So I, Google called me and I could fly to Zurich and have some interviews with them. That's great, nothing to lose, right? So I went there and I flunked the interview for the SRE. That turned out to be more of a sysadmin than I thought. Then they called back and they said, well, it seems that you fit better for this role called software engineering test, which is like test-interested software engineering, basically. I didn't flunk that interview, and I got a job offer down in Zurich. I looked at the numbers. This was before the climate disaster. So I considered flying there every weekend, but the numbers didn't add up. It would be too expensive, I realized. So I declined. And then they called me 3 days later and said, "Hey, we now bought this company in Sweden. Like, do you want to work in Sweden?" Okay, where are they based? They're based in Luleå. I'm not going to Luleå. Sorry. I mean, Luleå is a nice place, but I've lived my whole life in Stockholm. I'm staying here. No. They have a couple of people in Stockholm. Okay, what are they doing? They're doing video conferencing. The company is called Maratech. And I said, okay, yes, whatever. I had done some networking, so I had useful skills, but I don't know anything about video conferencing, and I don't know if I think it's fun, but never mind. And my wife said, you don't know so much about these companies, people, what they're doing. Are you sure this is going to be a good idea? And I said,
it's Google.
It's exactly. It doesn't matter.
I want Google on my resume.
Given the time, as soon as I get Google on my resume, I can go wherever thereafter. And that turned out to be true, because we have in Sweden, people have a very high respect for these strong brands.
Yeah.
And
I can't understand you.
Nowadays, it's not so hyped, but back then it was really, really hyped. It was almost ridiculous. When we went to parties, I didn't tell people where I was working until explicitly asked.
It was so hyped right then.
Yeah, it was ridiculous. So I ended up working with video conferencing, and the product they had, it was more of an acqui-hire than anything else, so that eventually got sunsetted. But we built the first version of Talk Video, it was called at the time, that eventually became Hangouts, and now there's the sort of third generation.
This is the first generation of Google Hangouts.
Yeah, exactly. And I have never been passionate about video conferencing, but that's fine because I ended up in the engineering productivity organization, and it turns out that Google's engineering productivity surpassed anything that I have ever seen before or after. So it was really educational.
So it's a little bit, this is the best school of life.
That was a very, very good school, yes.
So this is interesting. I mean, let's do the whole resume, but it would be interesting to take it as a separate segment to talk about what was the real standout topics here. But I think we should go to the resume.
But just
first.
very quickly, at least, what does an engineering productivity department do, or what's what their goals?
Tooling and processes for ensuring that the people are productive. It changed name actually from test engineering because most of the activities were around like automated testing and automation of quality assurance and so forth. And that is no little thing at Google because every line that you check in is tested not against your product only, but against everybody else that is dependent on it.
So this is true data product thinking, or something like this, that it really needs to run or be reusable. That's what I'm trying to say.
Yeah, exactly. And the Google is very, very coordinated. At least it was at the time. I haven't been there in a very long time, so I don't know how it has progressed. But the philosophy was that you move fast because you have the machinery, the coordination to and
so we are truly talking about industrialized factory thinking at the core.
Absolutely, yes, and minimize the latency from your idea to putting it in code to getting it in production. They didn't do like pure continuous delivery and continuous deployment at the time. I don't know if they do nowadays, but there were release cadences and so forth. I think that to some degree, for economical reasons, the number of tests that you have to run in order to throw out a release, with all of the performance regression tests, that amounts to a significant amount of money. So in smaller cases, in smaller settings,
continuous delivery
you can do continuous deploy. Yeah, exactly.
But this is a different scale.
And the economics are somewhat different. And there was also a culture shift, and that is really interesting because when I joined, the company was in this transition from relying heavily on manual testing, in particular for the mobile products. I mean, this was before the iPhone. But also with the web products and Selenium, I think technology like this was fairly new. And there was still a lot of manual testing, and it was decided from above that this doesn't work out. It's just too costly. So they said, in typical Google way, figure this out. Engineers, go figure this out. Yes.
I mean, testing is certainly a topic that's interesting, and I know you work at Spotify, and we had a lot of discussions there as well about what the proper level of testing, etc.
But let's finish the journey of Lal. I think this is an extremely interesting journey, and I already have 3 or 4 themes that I'm biting my tongue not to jump into.
That's fine.
So from Spotify,
from Google, and then
Google, I left when I felt that I couldn't learn so much anymore, and there was no other project available in Sweden for me to work on.
So the next step in Google would have been Zurich or
but
US.
Moving was not an option. I just had my first child and so forth, and not an option. So I joined a startup in a fairly early phase. It's called Recorded Future. They're now fairly big, based in Gothenburg. So I was one of a few people based in Stockholm. That was interesting, educational, not my cup of tea in the long run. I moved on. After a while, I was a bit tired of chaos and sort of sometimes the lack of like craftsmanship in software. So I decided to go to fintech to see if the amount of money in the area would actually make people care about quality. It did, in a sense that the customers were paying a lot of money. So when we did bad releases, they were very angry and they came flying over. On the other hand, the fintech overall is quite far behind in terms of methodology and processes and so forth. So it's kind of all evened out. I moved on from there to Spotify when I realized they were doing interesting things with data.
How did you get picked up by Spotify, or did you pick them up? How did that work? I'm just curious.
I said yes when the 10th recruiter called. So they actually called me twice after I had started working there as well. Somebody suggested I should ask what kind of salary I could get. Anyway, and the reason that took me to Spotify was really the data, because one of the realizations working from Google was how much value you can get out of data. You know, back in 2007, they were the only ones that did what we call really big data today. And it was so evident that, yes, you could like dominate the fields that you're in just based on what you can do.
Could you feel that with Spotify? What made you feel that Spotify was on that idea?
So I went to, like, I think Meetup had started in town at the time, and Spotify was holding Hadoop meetups and Cassandra courses and so forth. So once they started saying Hadoop, I realized they were doing interesting things with data. So I wanted to go there, and I ended up in a team that called Analytics Computation. So there were just a few teams doing data at Spotify at the time. There was like a data collection team and the computation team and some recommendation teams over in New York, and then there were some.
What year is this?
Analytics. This is 2013. And
where were you there?
I think it's about the same year at the start, actually.
Yeah, I think so.
Or
quite the same.
It's about the same year.
Same age.
And but the Hadoop cluster was, I'm not sure mature is the right word, but aging at the time. It was installed way back in 2007, so it had grown quite a bit. It was, I don't know, tens of petabytes or something.
We're talking Spotify was on the Hadoop train 2007.
Yes, and that was a stroke of luck. I think that was just, out of pure curiosity. This seems like to be like a fun idea. But that cluster is I think the most valuable computer system that I have ever seen. It has generated so much data value. I think it started in 2007 in a closet at Jon's department or something.
Yeah, Jon.
It's my friend.
Now you're being
a person at
Price
was there from the beginning.
In the closet, I love it.
And when the sun actually hit the cluster, it actually overheated. So then it went down, and they had to.
Wow, this is Spotify war stories. I love it.
Exactly. I have a collection of those war stories, but at larger scale.
But we need to talk, let's not do it now, but we need to talk about moving to cloud at some point. That's an interesting story.
That's also interesting. I think that the Spotify's journey with Hadoop, I'm going way on a tangent instead of my resume here as well, but it was really a stroke of luck, because early adopters of Hadoop have done really, really well with data. And I think there are two factors here. One, they are very technical companies and amenable to like adapt to things and so forth. But it turns out that Hadoop at the time could do very, very few things. It could store files. You could do batch computation with MapReduce, and you have this NoSQL database. And when you only have those things to work with, and you are kind of forced to, because you're at the data scale so that you're forced to use Hadoop, what happens is that you are forced away from the
siloed.
Yeah, from the silos of the databases, because the Hadoop cluster is really expensive to maintain. You need a couple of people full time, so you only want one of them, which means that you share all the data. And
you're forced to transparency.
You're forced to transparency. So, and because the security model is so bad, it's like readable to everyone as well. Whereas if you were in an Oracle database, you have very good security models, so you can lock down the data and you can keep your silos, right? So you achieve data democracy because it becomes transparent, and also because of the limited ways of computation that you have. You are forced to make to adopt the functional processing mode. You cannot no longer work in databases with mutable data where you can change a record at the time. You're forced to adapt it, like the functional paradigm, because the data is in the files is immutable. So you have to build these transformations step by step that we now call pipelines.
So basically, in a way, what is the shortcomings of Hadoop at this point in time in order to cater for the big data value is fostering a data-driven company, which is at the essence all about data transparency, and it fosters a coding paradigm, which is the functional
and the functional architecture.
The functional architecture.
That you do this processing in jobs that process files and so forth. And because they're all immutable, everybody can share them. You can't share a database because you don't know how the others will change the data, but the immutable stuff is easy to share.
So in a way, growing up in this context actually already here puts you on a different path, how you understand data products, what the data mesh could be, all this.
And Google and this was like my introduction to data. So I've never been good at databases. I still can't type SQL, right? I'm crap at it.
That's not really true. But okay.
That is, you've never seen me. I can do 4 lines and then I'm lost. So by stroke of luck, you were forced into building a factory instead of having your database as a pet. Right.
So this is really interesting because it really means that people growing up in the traditional relational database, growing up with those habits and what is best practice in the relational database, they actually have a really hard time moving on to the factory thinking now. And this is maybe one of the key challenges why the enterprise has a hard time to truly become data-driven.
Exactly, because they have well-established practices that they don't easily change, right? At high-tech
but for this, the wrong practices, maybe.
Exactly.
Good for relational, but not so good for factory.
And if the late adopters of Hadoop, that have lots of money, they have gone to the Hadoop vendors and say, well, we understand this Hadoop thing is great, or nowadays these cloud things are great, but we kind of like to keep our workflows and the way we work. Could you please implement SQL and transactions and so forth? And then they are eroding the whole value, which is to force you into better ways of working and better ways of collaborating. And that's the real value of big data.
I mean, I think this is an interesting topic about, in general, about parallel computation in different ways, and it can be a big data setting, it can be in HPC as you have worked in as well, or it can be in AI, which I would argue is all 3 different ways, but all have something to do with parallel computation. But before we move into that, I can see you being a bit questionable. Okay, but yeah, that's an awesome topic of discussion, I think.
I will continue to throw fire on this.
But before we
derail his attempts to control the flow here.
But let's try to finish up a bit about the personal background as well. So you worked at Spotify for a number of years, right?
And one of the core things we did there was when I came there, it was you needed a lot of folklore knowledge to put pipelines in production and so forth. So one of the first things we did was to do what is today called DataOps. Like we went to a workflow with continuous integration, continuous deployment, and so forth, and like enable the whole organization to build pipelines rather than just a few teams. And that then data use like skyrocketed after that in the following years.
So was that